Hey, 8th grade math, it's Mr. Hussey here. This is Wednesday. Just want to say a verse. God is our refuge and strength in ever-present time and help of trouble. Today we will be doing what I call a quasi quiz, which means seemingly a quiz, looks like a quiz, kind of a quiz. All right. So here's how it's going to work. It's quiz 5-2. Sometimes we'll do stuff like this even earlier in the year. I'm going to do half of the problems with you, and then you're going to do the other half on your own. And that's going to be a quiz grade. All right. So I will upload these documents and the video. Also, if you're kind of stressed out with the amount of work you have, this is going to technically be due Wednesday. But if you want to pass it in Thursday, that's fine. Because Thursday and Friday, there's only going to be one lesson in math for those combined days. Okay, so I think it's due, I forget if I made it due Thursday or Friday. Probably I made it due Friday. Or I will make it due Friday. So this week, after Wednesday, the quasi quiz, you'll have one more lesson, but that lesson will be due Friday. So if you need 2 days to do your quasi quiz and pass that in Thursday, that's fine. It won't be late. All right, so let's take a look at number 1. Find the slope of the line that passes through the given points. Okay, well, we know that points are always labeled x comma y. The x always comes first, the y always comes second. So this we're going to call this x1 and y1. And we're going to call this one x2 and y2. And then we're going to look back. You can use your notes for this quiz. You may just not use any friends, any parents, any siblings, anything like that. Okay? You can't use the internet to ask the internet these exact same questions. All right, so the slope is equal to y2 minus y1 over x2 minus x1. All right, that's one of the many formulas for the slope, right? So in this case, it's going to be 8 minus 3 over x2 is 13 minus x1 is 7. So on the top, that's going to be 5. On the bottom, that's going to be 6. So your answer for the first one is 5, 6. Okay, now be careful with like negative numbers. Be careful if you get something like minus a negative. Make sure you're careful with that. So be very careful on number 2. Be thoughtful and careful. Okay, you'll do number 2. Number 3 we'll do together. Okay, so same thing. These are always listed as x1, y1, and then this is an x value in the front, right, and a y value in the back. So if you get confused, you might put like x1, x2. Make sure you don't do that because it's always like an x comma y. All right. So we'll write down our formula: m equals y2 minus y1 over x2 minus x1. That's one you're going to want to memorize for high school. Okay, y2 is 4. Subtract y1 is negative 3. x2 is 9. Subtract x1 is 9. Okay, so that's going to be 7, 4 plus 3, right? So 7 over 0, which is an undefined slope. And you may need to look back at your notes to see how that works, okay? So anytime it's something over 0, that's undefined. If it's like 0 over 7, then that would be a slope of 0, all right? So we're done with 3. You'll do number 4. All right, number 5. Find the slope of the line that passes through the points in the given table. Okay, so we can take any of these points. Zohara asked a good question on this one day. I just like taking the first 2 points. Okay, but you could take this point and this point if you wanted to. Okay, but we're just going to call this x1, x2. We're going to call this y1, y2. So y2 is going to be -1 minus y1 is 6. X2 is going to be 0 minus x1 is a -4. So be careful with those negatives. Okay, you may need to pause the video if I'm going too quick here. -1 minus 6 is -7. 0 plus 4 is 4. So your answer would be -7/4. You could also say like -1 3/4, but for slope, they like to put it, because it's rise over run, they like to put it just like this, like an improper fraction. So that's your slope. All right, you'll do number 6. So that's number 5, you'll do number 6. All right, number 7. Find the rate of change in the first 30 minutes after takeoff. Okay, so we did these yesterday. These are like the real world applications. Find the rate of change. So the key thing here, you need to know that rate of change is your slope. So your rate of change, I'm sorry, let me zoom out here. Your rate of change is your slope. So write that down for number 7. So find the slope in the first 30 minutes after takeoff. Okay, so we got a few ways we can do this. This is your slant or your slope. After 1 hour, it's here. But for the first 30 minutes, your slope is like this. Okay, so you can think of it as like rise over run. You can think of it as like if you wanted to, you could make this point is 0, 0, right? And that's x1, y1. That's a comma there. That's like x1, y1. And this point here would be, well, x would be, what, 0.5. And your y value here would be 24. So that would be like x2, y2. Okay, another way you can look at it is your rate of change is in 30 minutes, like half an hour, 30 minutes. You're changing 24 feet in thousands. So your change is, you see how it says feet in thousands, so that's 24,000 feet. So I probably should have made this 24,000. So I like to think of it like that common sense way. So I like to think of it as in 30 minutes, you're changing 24,000 feet. And then obviously, since this is an open book, you can use your calculator here. So I'm just going to go ahead, grab my phone here, which has a calculator on it. I'm going to take 24,000, divide that by 30, and that would be 800 feet per minute. 800 feet per minute. Okay, so every minute, the rate of change there is 800 feet. Okay, now, if you were a little confused with that, you say, Mr. Esley, what about this x2, x1, x2, y2, y1? Okay, well, let's try it that way. y2 minus y1 over x2 minus x1 is your slope, right? So in this case, y2 would be 24,000 feet. Based on this number here, I've originally put 24, but it says in thousands, so that's 24,000 minus x1, which is 0, over x2 would be 0.5, but that's in hours. So let's think, what's 0.5 hours? What's half an hour in minutes? So we're going to put 30 minutes minus, or so let's say you left it at 0.5 hours. Let's just say, then that would be minus x1 is 0. So on the top, you'd have 24,000. On the bottom, you have 0.5. Okay. And then half of, if you divide something by half, it's like times that by 2. So 24,000, I'm just typing it in to make sure, divided by 0.5 is going to be 48,000. That would be feet per hour. Okay, so either 48,000 feet per hour or I think 800 feet per minute makes more sense. So like, if how many minutes are in an hour? There's 60, right? So if you took this number right here and divide it by 60, you're going to get that. Okay. So either one of those answers is acceptable. I like it this way, personally. All right, so that's 7. You're going to do 8. Find the rate of change from 1 hour and 30 minutes to 3 hours. So you're going to have to come here and find the rate of change from here to here. Okay. It doesn't look like it changed at all, so you might want to consider that. Or you can make like x1, y1, x2, y2, and do your math, but it doesn't look like there's any change there. All right, number 9. Find the rate of change from 4 hours. So that will be here. Here's the rate of change from 4 hours. I'm sorry, my fault. It says find the rate of change from 4 hours and 30 minutes, which is right here where this dot is. 4.5 hours, right? 4 hours and 30 minutes. Halfway between 4 and 5 hours is this one, to when the plane landed. Okay, so the plane landed here because the altitude, the plane looks like it took off here, and then it looks like it landed here. Okay, so what's the rate of change here? I'm going to do this the common sense way. Well, that's a 30-minute time frame, right? From 4 hours and 30 minutes to when it landed. So we have, for number 9, we have something over 30 minutes. Well, it decreased by, what, it started as 16,000. And it dropped 16,000. So that's going to be negative 16,000 because it dropped, right? So if I take 16,000 divided by 30, that's about negative 533 feet per minute. Okay, so it's dropping. When it's descending, the plane is dropping. When it's ascending, the plane is rising. Now, if you plugged in your y2 minus y1, let's just think of it here. Your y2, your first y value would be this one, because that's where the problem starts. Your second y value, so your y2 would be 0, right? And then you'd be starting with 0 and subtracting 16,000. That's why on the top, you're going to get negative 16,000. I just knew that because you're descending, okay? So make sure that's a negative answer. Then you'll do number 10. Okay, 10's much like the problems we did yesterday. You'll have to see the temperature difference and how many hours there were there, and then find the rate and change during that time. All right, let's look at 11 and 12 here. Okay, it says to identify the slope and y-intercept of the line, then graph the equation. Okay. So our slope is always the number before the x. So for number 11, in this case, our slope is going to be 1. Because there's no number there, so it's like 1x, right? And our b, or where it crosses the line axis, is always the y-axis, I'm sorry. Is always this, so that's negative 4. Okay. So that means there has to be a dot 1, 2, 3, 4 down. So I'll put a dot there. Okay. And we know that slope means rise over run. So that's going to be 1 over 1 will give us 1. So every time I run 1, I rise 1. I run 1, I rise 1. Run 1, rise 1. Run 1, rise 1. Same thing in this direction. I got to go the opposite way because if I run 1, rise 1, right? So I got to go reverse. If I run 1, I rise 1. So that's how you would plot your line. Okay, now, if you don't have the ability to print this out, which my kids don't, okay, because our printer's not working. I just happen to have these printed out before the COVID-19 pandemic, so I took these home, and that's good because I can now upload them for you. But if you don't have this, then take your time, do this on separate paper, draw yourself a little graph, okay? Make sure you show your work, and then show some points. So make sure you know that this is like 0, -4. Make sure you know that this one's like 3, -1, and maybe this one like -2, -6. Okay, so if you don't show that work, you will lose points. You do need to show some work on that. Okay. All right, number 12, you're going to do on your own, but it's going to cross the y-axis at +3. That's going to be your first point, right? And then your rise and your run, I like to put that negative up here because when you run 4, you rise 1. I'm sorry, when you run 4, you would rise a drop of 1 because the negative will go up there, so you'd be dropping 1. So this line, anytime you have a negative up here in the front, you know that your line's going to be in this direction, right? Like you're going downhill skiing. If you're going left to right, you're going uphill here. If you're going left to right, this will be a downhill slope. All right. Okay, 14 is an easier one, so you guys can handle that. 13 has a fraction, so let's look at 13 together. Our slope is the number that comes right here, so that's 5/3. Remember, that means your rise over your run. Our b is the +2. That's where the line crosses the y-axis. So this one goes blah, 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 +2. So it crosses here at 1, 2. Okay. And then every time I run 3, so 1, 2, 3, I have to rise 5. 1, 2, 3, 4, 5. So if we think of it the other way, if I ran 3 this way, right, I'd have a drop if I have 1, 2, 3, 4, 5. Because if I went this way, it'd be 3, 1, 2, 3, 4, 5, 3, 1, 2, 3, 4, 5. So this one's 0, 2. This one is what, 3, 7. And this one would have to be what, -3, because we're going over 3, and 5 down from 2. So -3. There's your line. Okay, so if you need to pause the video, if I'm going too fast, please feel free to do that. All right, number 15. The slope is, you'll do 14, right? 15 we're doing together. The slope is the number in front of the x. So -7/2 is our slope. I put the negative on the top number. That helps me. You could put it on the bottom if you want. You just can't put it both because then it's going to be a positive number. Since there's nothing here, there's no like +1 or +2 or -1. It's almost like saying +0 or -0. So that means the line's going to cross at 0 up and down, right at the origin. All right. So for B, you can put +0 or 0, or if you leave it blank, that's okay. All right. So now for our slope, remember that this is your run. It's always your rise on top, your rise over your run. That's something you're going to want to memorize for the rest of your life, pretty much. Because someday you'll even be helping your kids with this, but everyone needs to know that in high school. Rise over run. Slope is rise over run. So when I run 2 units, remember you always run to the right, okay, when it's a positive run. Now, if you happen to put your negative down here, then yes, you would be running to the left, but I haven't taught that at all this year. I'm always teaching you run this way. So you run twice to the right like you're reading a book, and your rise is -7. So you have to drop 1, 2, 3, 4, 5, 6, 7. Because a rise of -7 is like a drop of 7, okay? And then if I went 2 backwards, then I'd have to go 1, 2, 3, 4, 5, 6, 7 up this way. Okay. So there's our line. It makes sense, right? Because our slope is negative, so it makes sense that if you're walking like the way you read a book, you would be going downhill, right? So this point would be 0.00 if you don't have the graph paper today. This point would be -2, -7, and this point would be 2, -7. All right. Now on 16, be careful, because 16 is one of those tricky ones we did the other day where the slope is, remember, the slope isn't necessarily the first number. The slope is the number right in front of the x. So because there's this form we want, this is y equals mx plus b. So in this case, it's going to be y equals -5x. And since there's nothing in front of here, that's going to be a +4. So before you do your m and your b, make sure you set up the equation. Make sure you put that -5x in the front, like we did a couple days ago. All right, number 17, 18, we're almost done. 17, write the equation of the line shown on the graph. Okay, so here's the line shown on the graph for number 17. So it's blah, 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 plus 1, 2, 3, 4. It crosses at +5. So it's blah, 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 plus 5. Because remember that y equals mx plus b. Now, so our x, we have to have an x right there. And then our slope, or our m, remember that we get our slope, show your work like this. Our slope is equal to our rise over our run. So in this case, if I run 1, 2, 3, 4, so my run is 4 from a point on the line, then I have to rise 1, 2, 3, 4, 5, 6 in the negatives. So my rise is a -6. So over here, if I reduce that by dividing by 2, that's going to be -3/2. So my slope is going to be -3/2 x. My slope is going to be -3/2, but my equation is going to be -3/2 plus 5. And once again, if you need to pause that or rewind a little bit, you can. Okay. Thanks, guys, for your patience. I know this requires effort. This is not easy. It requires concentration, effort, patience, not getting frustrated, right? So thank you for all your hard work. 18 is just the same thing as 17. It's just you have choices, right? So right off the bat, you know it crosses at -2. So right off the bat, you know it's either C or D. All right, and then you just go from there. But show some work for that one. So this is technically due Wednesday. All right, but like I said, if you passed in Thursday, that's okay, because Thursday and Friday we have one lesson combined. No helping each other on this one. No asking friends. No asking older people at your house. If you email me something, I'll probably try to help you on like one question or give you a hint or something like that if you really must. But I think this is doable. I think you can handle this on your own if you look back at your notes and you're careful looking through this video. Thanks, guys. God bless you. Have a wonderful day.